We only discussed.
Yeah.
We discussed only.
One topic only, yes. Okay, so second topic in 9.2 is basically this one. Yes. Actually, these questions means from 15 to 22, same thing. You have to check geometric series, okay? We have done already this case. Same thing. You next divide by previous. If it is same, it is R. If it is R, geometric series, understand? If R is less than 1, so converges, absolute value, okay? If more than 1, so diverge, please. So it's not something new, same thing, please. Now here, 23 to 30. This is a second topic you can say we have discussed now. Actually, now is an application of geometric series. So from 23 to 30, these are repeating decimals because bar mean is coming again and again infinite times. Okay. So you have to write the answer of this repeating decimal ratio of two integers. Means the decimal you have to change to fraction. Up number, down number, please. Should be integer, means not any decimal place. Okay? And basically, this application of geometric series means how you can solve a problem with the help of geometric series. So, what is the problem? The problem is that this is 1.24123 means the last 3 digits in this decimal number. It has bar. Bar means 1, 2, 3 is repeating, coming again and again. After infinity. So you write the answer as fraction.
Yeah.
Okay, then you have to write the answer as a fraction.
We started this course.
The
We never wrote our answers in fraction. This entire course. No.
we write many times all the answers are in fraction or complete number. We don't accept the answer in decimal.
We write it like something of something.
So it's called fraction.
I mean decimals.
Decimal, yeah, exactly. We never write, right? Same thing here. This is decimal. We have to convert into fraction.
Yeah.
For 9 numbers. Up integer, down integer. Okay. So let's start with how we answer this question, please. This is 9.2, topic number 2.
What's the topic about?
Topic is that write the repeated decimals as a fraction.
Here, sine one minus sine 2x over 2. It was sine 2x.
So
It will be sine 4
4x.
and down 2 remain 2. That doesn't change, right?
Okay.
Dr. Istikif, I asked you a question at the end of the class about.
Yeah, you can ask. Yeah.
No, it's not about Muslim.
Okay.
It's about previous Dr. A.
After class, we can discuss. No problem. Okay, let's start with question number 28, 1.414, please. So, question 28, 9.2, question 28, please. Question 28. One point
I'm sorry.
414 and bar. Understand? Which is basically you have 1.414, 414, 414, and of course, continue. Right? Please. This number, which is basically 1.414 is repeating. We write answer as a fraction. Okay. So please note down. Means write as a ratio. Ratio means fraction. Ratio of two integers. Integers means up and down, only complete numbers, not decimal numbers.
This is a part of our final space.
Yeah, fine question. Exactly, fine question. Now, step one. We're going to do step one, please. Actually, this question has two parts. One part is not repeating, the other part is repeating. Yes or no? So we can make separation. Means let's say it is 1 plus, and then you have this 414, 414, 414, and of course, can be separate. You can make it like this one. Means I just make separate one, no?
0 point.
No. No need for that. I just take two parts. Means the number before decimal and the number that number which is repeating. Okay. Now this 1 plus remains as it is. Now look at here. 4 1, the first row 414. Okay.
How many times should you repeat it when writing it, or it doesn't?
I think if you just write 3 times, it's enough. Now please tell me, to reach the first group, 414, first group, how many decimal you remove?
3.
Yes, 1, 2, 3. Because when this decimal comes here, you get the first group. Yes or no?
Yes.
So how many digits we move? 3. So what you do is write 414 divide by 10 power how much? 3. Please, again, try to understand. This is the question, please. This is the question. 4.414 repeating. It is repeating, please. So I just do 3 times. 414, 414, 414. Then we check. The first group will come after how many decimals?
3.
3. Okay. So I write the first group divide by 10 power 3. Okay. Now plus second 414 comes after how many decimals?
6.
Okay. So 10 power
6.
3. Good. The next third group
414 over 10 to the power of 9.
9. And of course it will continue like that.
And you keep doing it until you reach.
No, because we cannot, it's an infinite phase. Okay, now. Don't, I told you, you can make bracket again, don't worry. Okay, now please check. Is there a geometric series? Yes or no? Next, divide previous.
Yes.
Next, divide previous. We have same common ratio. Okay, so yes, it's confirmed. It's geometric series. How much R?
10.
1 by 10 power
3.
3. Right. Sorry. So yes, you're right. Basically, if you get R, you can write the next 414 divided by 10 power 6 divide, change to multiply, flip 10 power 3 divided by 4, next divide previous. So basically, you are getting 1 over 10 power 3. This is my R. Okay. Less than 1 or more than 1? Less than 1. So it is. The number is point the sum there. Point the sum is. So one thing is confirmed. This question is basically geometric series. This one is geometric series with common ratio 1 by 10 power 3. And here any question? Okay. Now, sorry, what is not without answer? Just wait. At the end, we have to add one. Next, divide previous. Only from the, yeah. That's why I told you I'm working only the bracket part. Yes. Yes.
I did not understand from the beginning, how did we separate 1 plus?
Actually, see, this question has 2 parts. One part is not repeating. Look at here. One has no bar, it's not repeating.
Yeah.
and 4, 1, 4 has repeating. Only separate repeating and not repeating.
This side.
Yeah, it's a part of the procedure. Basically, they're adding basically. Okay. At the end, we add. Okay. Now, please find the sum of this geometric series because it's confirmed. The geometric series, you get the arc. Okay. So please, this is 1 plus as it is. This is 1 plus. Okay, sum. What's some formula? We learned a sub 1, first term. In this geometric series, what's the first term?
4, 1,
4, 1, 4 divided by 10 power 3. Divide by 1 minus r. R how much? 1 over 10 power 3. Please just solve this part, please.
The final answer is 157 over 111.
I'm asking only about this part. Okay?
This part,
Yes.
46 over
So this is now 1 plus, yes, this is how much?
46 over 1, 1, 108.
1, 1, 1. 1, 1, 1.
Yes.
That's it? Okay, good. Now, add 1.
157.
1 plus this one, 157
57 over 100.
over 1, 1, 1. And this is your answer. This is the ratio of your two integers. Check the answer. 157 divided by 1, 1, 1. Are you getting same answer? This one. 1.414, 414, 44. Yes or no?
Yes.
Confirm. Your answer correct. One divide one. Flip.
Yes, so option multiply, right?
Yeah.
Exactly.
Then that two and this we cancel. Understand the procedure?
Yeah.
Okay, let's take one more question, please. On same topic. Let's start with 30th question, please. No, sorry, 29. 1.24, then 1, 2, 3. The last three, 1, 2, 3 is a repeating, okay?
29.
29. 1.24, then 1, 2, 3. 1.24, so this is 29. Question 29. 1.24, then 1, 2, 3 is basically bar. Means this is repeating. Clear? Okay. In the last question, how is started?
We took the one as separated from the repeated number.
Huh?
Yes.
So how we make separation?
So 1.24 plus
The part which is fixed, not repeated, and that one which is repeated. So which part is not repeated? 1.24. Then plus.
0.
No, not 0. No.
1, 2, 3, 1.
So yes, 1, 2, 3, 1, 2, 3, 1, 2, 3, and you can turn it fixed. I told you 3 times enough because we need to generate the geometric series. Okay. After that,
Now 1, 2, 3 over 10 power 3.
Now-
Plus
basically we have to check now. Means 1.24 plus. Okay. My first group 1, 2, 3. If I want to reach to my first group, which is 1, 2, 3, how many decimals I have to move? 1, 2, 3, 4, and 5. So my first group will be 123 divided by 10 power 5 plus
1, 2, 3 over 10.
my next group 1, 2, 3. How many times? Sorry, how much my decimal will move? 10 power?
10?
No, I'm asking. My next group now. So next group 123 divide by, yes, 10 power how much? 10 power
8.
8.
How do you not see?
To count. Now you are here in first group.
Yes. You want to
Now
go?
I need the second group.
So we're at
So-
5. You need 3.
Now it is 3, then again 333. In the starting, it was 5.
Just
Exactly.
And then 10 power 11.
10 power
11.
11. Yeah, good. So it's so plus third group 123 divided by 10 power 11, and of course it is continuing infinitely. Okay, now check. Is that geometric series?
Yes.
Next, divide by previous.
this is the same one, sir.
Okay, so sorry, 1.24 plus. If it is geometric series, how much are here?
1 over 1,000.
1 over 1 by 10 power 3, right? This is R, and of course, less than 1 and converges, find sum. A1, first term, how much?
123 over 10.
123 divided by 10 power 5, divide by 1 minus R. R is 1 over 10 power 3. Okay, good. So now please solve this portion, only this portion, please.
That's 41 over 33,000. That's what's us.
R means next divide previous, you get R. Okay. So now after this, you have done this calculation. You told me it is 21
Over 33,300.
3. This one.
Yes.
Okay. Now please add in this answer, add 1.24 and get the answer of fraction, please. Now 1.24 plus 41 by this, we need the answer in the ratio of two integers, not decimal, we need fraction.
But we do for each and every one.
Sorry?
We do for each and every one, like we did for 10 to the power 5, 10 to the power 8, so on. So the answer
I
is
don't
this.
understand. Means first one that are 5, the next is 3 more moves. 5 plus 3, 8.
Yeah, so we do one, we put 8 in the equation for the R.
From here.
Awesome.
This is A1, first term, which is 120 divided by 5.
Okay.
Divide by 1 minus R.
Okay, you're gonna
R
do this.
is 1 over 3.
Okay, are you gonna do the same for 1 to 3 over 8 to the power 10 to the power of 8?
What same?
Like the same thing here.
Actually, this is the arithmetic series. This is the first term. And the R is next divided by previous or next divided previous. I got R, which is 1 over 10 power 3. Now use these values in the formula of sum. What is sum? Sum is first one A1 divided by 1 minus R. Use this formula. Did we use formula here?
Good.
Yeah.
Different answer. Equations.
So when we substitute this one, you're not getting this one? Means this one, 123 divided by 10 power 5. Then again divide by 1 minus 1 over 10 power 3. So we're not getting the same answer like 41 divided by 3, 3, 3, 0, 0. Yes? Yeah, he said yes.
No, I said no.
Okay. Yes, plus 1.24
Now the answer is, and the answer is
No.
equal
is wrong.
to the.
Not accepted. Not accepted. Answer we need decimal. Sorry, not decimal. Integer. Ratio of two integers. Fraction. No decimal.
Our calculations is not correct, so. Yes, you think.
Huh? Okay, look at it. This is 1.24. And it is decimal part, okay? When you are adding here, you are not getting fraction, right? You are getting decimal answer,
Yes.
which is not allowed. So do one thing, change this one into fraction, divide by 100 and it. So 1.24 means 124 by 100. Yes or no, please? Can you write 1.24 like that? Okay, now make a common denominator. And that's it. So now here, please. Now here is 33300. Here is 100. How I can make this same? Multiply by 333. Also up. So that you get the same common denominator. So now you have common denominator 33300. And up how much please?
So
333 times 124 and plus 41.
41,350.
41,333. Just check. When you put this up and down in the calculator, it's giving you one more simplified answer.
It gave me 41,192. That's the same answer.
No. Is simplification possible further?
Yes.
This way.
41333 divide 3300 decimal.
Hey, you get 1 point.
Okay, that's it. You are getting the same answer. Means 1.24, 1.23, 1.23. That's it. This is the answer.
We stop before the step.
Huh?
What happens if we stop before the step?
Before which step?
My square.
Yeah.
Like, just stop.
No, please, we need the
Once.
complete answer, please. We need ratio of two integers. See, it's a ratio. And two integers up and down. We need this format. This is the format. Ratio of two integers, please.
Yes.
I hope you get the idea how to answer this question. Clear?
Yes.
Actually, this is one of the applications. I mean, how you can use geometric series to solve, these problems. So the problem is that you have a repeated decimals, and we need now as a fraction. So we use here geometric series. No need for this 26. D is just a number, so no need for that. Let's put a general number. Others we can try. Don't worry. It's same like that before. Okay. So this is topic number 3. Sorry, two topic, number 2. Actually, there are 4 topics. Overall, in 9.2, we have 4 topics. So first topic was related to geometric series. Second topic was this one, repeating integers. Topic number 3, please. Actually, we will only discuss 3 topics. Topic 4 takes time. We don't have time, okay? So topic number 3, please. Topic number 3 is called test for divergence. Test for divergence.
This one,
9, all 9. Topic number 3, last topic. Test for divergence. Now, as I told you, in chapter 9, overall, we have to check the given series converge or diverge. Different method we use. In exam, in final exam, we mentioned use this method, use this method. We mentioned, okay. Now, there is one procedure which is called test for divergence. This method basically helps you to determine, to find series divergence. This test never ever tell you series converge. No. Either it tell you series diverges or this test don't fail. There's no option in this test. It will tell you that the series converge. No. That's why its name is what? Test for that. It only help you to confirm that it is diverge. Okay. It will not say anything about converge. Clear? No. No down is the rule. Let's say you have a series A sub n. A sub n is any question. Any series name is A sub n. Apply limit n approaches to infinity is if you apply the limits on the A sub n and answer is not equal to 0. Answer is what? Not 0. This implies that series diverges. This implies that series diverges. Series diverges. And that's all. This is the rule. This rule is called what? Test for divergence, or simply divergence test. Divergence test or test for divergence. This is the rule. You have to calculate the limit or infinity of the question. If the answer is not 0, what's the conclusion? Diverges. Okay, that's it. There is no second option available in this test. For example, what happened here? In this calculation,
If it's 0,
if it is
0.
0, then converge.
No.
No. If the answer of your limit calculation is 0, this test doesn't help you. Means situation is that inconclusive.
Change method.
Change method. Yes. Change method. Exactly. Okay. Change method. Yes. Okay. Now start some questions, please, on this topic. I take some questions for your interest. Let's say we start. Yeah. Are there? Now, for example, okay, 31. Sigma 1 n by n plus 10. Question number 31. N by n plus 10. Okay, question 31. Question 31. Sigma n is equals to infinity n divided by n plus 10. Now, by using divergence test, please check this series converge or diverge, please. So, limit n approaches to infinity, n divided by n plus 10.
And that's.
You know very well, here we can use,
And this starts to n equal to 1.
okay, 1 to infinity. Okay, thank you very much. 1 to
We can use the start to.
now, here we can use logarithm rule, you are right, or you can use shortcut, up degree, down degree, same. So answer how much?
1,
1, which is not equal to 0.
which.
So, huh? Wait, wait. If the calculation answer is not equal to 0, series what? Diverges. What's the answer of our calculation?
Series.
1, which is not equal to 0. Yes or no? So diverges. Yes. So this implies that this question number 31 is diverges. This series diverges. Understand? Yes or no, please? Yeah. Let's take question number 34. N divided by n square plus 3. Okay, please. 32, before you take derivative, sorry, limit, first multiply. Before you apply local rule, multiply, okay? Then you can get the answer. N by n square plus 3. N by n square plus 3. Sigma n by n square plus 3. Question number 34, please. And it is 1 to infinity, right? Okay. So a series given to us, we have to check it is converged or diverged by using divergence test. So start limit. Limit n approaches to infinity, n divided by n square plus 3. You can use again shortcut. Up degree how much? 1. Down degree how much? 2. So if up degree more than down, limit on infinity, what's the answer? 0. So it is
Change method.
inconclusive. Yes. This method is not helping you to check it is converge or diverge. Use other method, please. Change the method.
Is there another method or not?
Oh, yes, many. In chapter 9, we have only methods. We have 10 methods. 10. In total, we have to learn 10 methods to check function, series converge or diverge.
You have to keep up trying with us.
No. The method we mentioned, it works. Okay.
Doctor, how many sections do you have in chapter?
7.
7?
Okay. Now, before we go for next topic, please, can you just revise how many series we have done or test?
DCT and.
No. Wait.
GA.
Yes. If you exactly, if you combine, actually DCD, LCD now again come. So just wait for that. P series,
G.
G series
A
and test of divergence. Three things we have done to check series converge or diverge. Please.
All these are.
P series has property when converge, when diverge. G series has property when converge, when diverge. And now test of divergence also told you if the limit on infinity calculation is not zero, it means series. So until now we have learned three rules. Oh yes, if you combine LCD and DCD becomes how much 3 plus 2? 5. Yes, so right now you have now 5 different methods you have to learn to check the series converge or diverge. So anyway, DCD, LCD again comes in 9.4, okay? Yeah, please.
Dr. Rajat, if we have inclusive,
Now, just like inclusive.
said change method, but.
Yeah, but actually I told you in exam, we don't give you any question where you have inconclusive, then you change the method.
Have thanks.
Yes, you have the answers. You have them. Exactly.
Doctor, in the exam, like if you asked us, we have to try each method, or you mentioned, because you said in the exam, you just say, see if it's converges.
No, I'm talking about the exam from chapter 8. In chapter 8, one of the questions, the last question will be like that. By using any comparison method, we discussed two comparison methods, please. 8.8, LCT and DCT. So that one you have to check who is working. I give you already one shortcut.
Same.
If the question is sine cosine, only DCT work. If it is not sine cosine, okay, I give you one more idea. LCT is the best method. LCT. So my advice is that if you have option that which method you have to use, DCT or LCT, go for LCT directly, don't waste time. Oh yes, if it is sine cosine, you know very well only DCT works. If it is not sine cosine, always go with LCT because LCT is much stronger method than DCT. Clear? Yes. So I have the idea. Okay. Let's take some more questions. Means randomly. Please note down. It's not necessarily that all the question can be answered by divergence test. No. There are many questions who cannot answer by divergence test. Please. Again. Actually, now this is this series. If you simplify, this series get this one. 2 by 4 and plus 3 by 4. So which series? G series, directly. Is a mixture. The questions are mixture. So it is a geometric series and it is converges because 2 by 4 less than 1, 3 by 4 less than 1. They are converges. You can find some, you can add a sum. Okay. So anyway, means I just give the idea how you apply these test for divergence, please. Okay, test for divergence. And in test for divergence, what you need, you only to find limit on infinity, and you'll use which rule? L'Hopital rule, please. Okay. Any limit question, you have to use which rule? L'Hopital, please. Clear? And you know very well when we can use L'Hopital rule if it is 0 by 0 or infinity. Yes. Actually, topic number 4 is this series. Is that? That's nothing. So takes time, please. I not give just because otherwise I have to spend the whole class in the 9.2. So I have done 3 topics. Please. Number 1, geometric series. Number 2, repeated decimals. And number 3, test for divergence. Okay? Good. You get 2 questions from 9.2. From these 3 topics, 2 questions. Clear? Good. 9. After 9.2, 9.1, I told you no need. This is a sequence. Actually, in 9.1, how to check sequence converge or diverge? Same procedure, divergence test. If the answer, okay, one difference. When you apply the divergence test on sequence, please, when you calculate limit on infinity on sequence, if answer is a number, sequence converge. If answer is infinity, sequence is divergence. This is the only difference in sequence, converge or diverge. Okay? So we are not confusing here. So 9.2, I told you 3 topics. 2 questions will frame in the final exam from these 3 topics. 9.2. Okay. Now, please 9.3. So you can start with the 9.3 or 9.2, please. 9.1 you can skip, it's fine. Exercise number 9.3, please. 9.2. 9.2 finish, yes. As I told you, chapter 9 is basically we are learning different procedure, different methods to find out series converge or diverge. Until now, LCT, DCT, P series, G series, and divergence test. Okay, we have done. Now we learn one more technique. Final exam. Final.
Yeah.
Use LCT. Use GCT. Use test for divergence like that. Geometric series you have done by yourself. I told the shortcut how you check that this question is geometric series, yes or no. How? Constant, power, n. And one more thing. So this case R, but if you have sign controller, so R is negative, minus. Very good. So you can note down these, keywords, short, things. You can review. Okay, 9.3. You know which method we have 9.3? Squad integral test. Which test? Integral test. And this is only one topic in chapter 9 where we need what? Integration. But this is not any new integration. When I give the rule, you will say, oh, this integration we have done already. There is no new technique of integration, please. It's a procedure, only procedure, how to check that the given series converge or diverges. But yes, here we, with the help of integration, we have to confirm that the series converge or diverge. Okay. What is the rule? If integration answer a number, so series converge. If integration answer is infinity, so that's it. So you need integration of the point. But actually here you have to check 3 conditions. How many conditions? If a function has these 3 conditions, you can apply this test. If any one condition fails, this test cannot be applicable. However, in the exam, we give you that question who has all 3 conditions, right? Yes. So don't worry about that. Means the 3 conditions already justified. No need to check. You have to check only one condition because it has marks. One condition you have out of 3, one condition you will check. Okay? Because this condition has marks. Anyway, I will let you know. Before you apply this test, make sure number 1, function is what? Actually, in short, we say PCD. We have to check PCD. Positive. The function must be positive. Understand?
Yes.
Number 2, the function must be what? Continuous. P, C. Number 3, D. Any idea? No, because it is integration. It's called what? Yes, D is easy. If these 3 conditions are okay, you can apply this test. Which test you can apply? The name? Integral test. So generally, you should know the requirement means every function cannot get the integral test. Only those questions get the integral test who has these 3 conditions. If they are positive, if they are continuous, and if they are decreasing, then you can apply this test. Yes, please.
Which one should we check?
Decreasing. You must have checked in exam, it has a mark. Now tell me, how to check decreasing function?
Derivative.
Yes, first derivative test. You are right. Yes. Positive continuous, one second, you can check, oh, positive and continuous, no need. Yes, we need decreasing, and here we have to check, apply first derivative test, exactly. So let's take a question, please, from this topic, please. And then we apply the integral test, and I told you, when you get the integration, if integration answer is a number, a finite number, so series converge. If the integration answer is infinity, series, that's it. There is no other, can say, rules. Okay, so let's start the question, please. Let me open the integral test. The 9.3, look at here, integral test. Okay, integral test. Okay, we can go for the exercise. Maybe on page number 70, 570 maybe. Exercise. Yeah, I'll go back. 569. Okay, this is 9.3. Applying the integral test. For integration, same rule which you have done already. You have done now enough integration, okay? You know how to integrate the questions, please. Okay, let's start with number 6 question. Number 6, sigma 1 over n times ln n power 2. Number 6 question, please, 9.3. Number 6, 9.3, start from 2. Okay, so question 6, sigma n is equal to 1 to infinity, sorry, or 2, minus 2,
2. And is equal to 2.
and it's 2 to infinity,
1
1 over n times ln n
square.
square. Okay. As I told you in exam mentioned, by using integral test, determine the series converges or diverges. Okay? Good. Now, step number 1, you have to check 3 conditions. P, C, D. Okay, number 1, P is there. P means positive. From 2 to infinity,
Yes.
substitute any value here. Are you getting any number negative? Put here 3, 4, 5, because it's very clear, all n are positive, right?
Yes.
There is no negative sign available here. So n is positive, square, make the positive answer is clear. This function is positive from 2 to infinity. Clear? P, yes, done. Number 2, C, continuity. Is there any number you substitute here, get undefined?
No.
Come on.
From
2 to infinity, please.
No.
Start from 2. Any number make the answer undefined?
no.
No. So continuous?
Yes.
Yes. Number 3.
But we have to be
Now, yeah, decreasing. We have checked now. Third condition, what? Decreasing. How to check decreasing?
There are two first.
Now, please, now start your calculation for the third condition. These two, no need. Just verbally you can write, no problem. My function f is, so let's say my function f is, now it's your choice. If you want to work with n, you can work with n. If you say, oh no, I don't say and I will go with x, make it x. It's your choice. Sometimes, oh, and they're confused. So don't worry, please. N is x, please. It's your choice. Okay, this is my function. 1 over n and square. I need f prime. What should I do? Huh? Correct? 1 over this one, correct?
Quotient.
Up and down.
Quotient rule.
Product or quotient?
Quotient.
Yeah, please tell me, product or quotient?
If we are
Up.
work with the product.
Both? Okay, look at here. You are right. product.
1 over n times 1 over.
But not now. But not now.
We should figure it out.
Take it up. Exactly. Because my numerator is constant, no need for a quotient. If any numerator or denominator is constant, don't use quotient. You can use, but it's fine. Do one thing, put the thing up, please. It becomes now, sorry, n power -1 and ln n power how much negative? And now use the product rule. UV, yes. Okay, please start F prime. F prime, okay, so yes, U prime. If you don't mind, please, actually you should use short period. X power -1 derivative, we all of us knows it is -1 by x squared. Use shortcuts, please. X power -1 derivative, how much? -1 by x squared. Right now, I'm using n, okay? And ln n power -2 as it is plus. Now, n power -1 as it is. Now, what is the derivative of ln n power -2? -2 ln n -3 times 1 by n, because inside functions ln n is derivative is 1 over argument.
Chain.
Chain. Yes. So we have done our differentiation by using product rule. Now they simplify so that we can check the decreasing property. Okay. By the way, how check decreasing property? How?
Zero.
Huh?
Zero.
Find the critical points. Yes. Good. First, simplify, please. First, simplify. Okay. How I can simplify? Can you help me?
And take it.
Take it down, yes. So negative sign 1 over n square and take it down ln n and also what? +2 square. Good. Okay. Positive times negative. What?
Nice.
Negative. Okay, good. N power -1. Please take it down. So 1 over n. This also you have n. So and move ln n power 3 down to make it positive. Please tell me from here to here. Any question? Yes.
I'm sorry, what did the -2 go?
Where's the minus?
Oh, I'm sorry. -2 is here. I have minus. I'm sorry, I forget 2. Thank you very much. It is 2. Yes, yes. Any other thing? We just move the negative exponent down. Is okay? Right. I need simplification.
Yeah, 1 over.
2.
Confected?
1 over. Take it.
Common denominator. Make the down part same. Because you are required critical points.
You multiply by n or
Not ln.
ln.
So we need CP. CP means the derivative 0 or derivative undefined. I need fraction, please. Okay, so common denominator. So what should I here multiply?
ln.
ln n. Very good. When you multiply ln n, so up and down, so become what?
Q.
Yes. I multiply ln up and down. So down, before it was 2, again become 3. Clear?
Yes.
What is common denominator now?
Uh,
N square and ln n power
Q.
q. 3. Up is what?
Q.
ln n minus 2. This is my first derivative in simplified form. Hope you understand.
There is negative sign up.
There is negative sign. Yes, you're right. Thank you very much.
This is negative ln2 or ln10.
Wait there.
ln n.
Oh, sorry, not 2. ln x and yes, thank you very much.
Equals to 0.
Yes, just wait. So get that prime. Now for the purpose of decreasing, you know very well, we need now x value, this n here. So CP, critical points mean your derivative becomes 0 and then become undefined. So your derivative is like that. Up is n, down is n. When this derivative becomes 0. When the answer of derivative becomes 0. When the numerator is, yeah, so put the upper part 0, get n value please. So look at here, minus ln n minus, sorry, ln n minus 2 is equal to 0. Yes. Okay. Please, I need from here an answer. Means X answer. So what should I do for n answer? Okay. Means I can move negative to the side. Or I can move L and N to the side. So I get now L and N is equal to negative 2. Agreed?
Yes.
Very good. I need N. How I can set? Take both side what? E. So when you take both side E, N cancel out. You get from here N, which is E power how much? Give me its value, please. Come on, in decimal, what is that? 0.135. 13. Okay, check. Is it coming in your domain line? 0.135 is coming in domain line. Domain is start from where? 2. 0.2 coming in the 2? Tell me.
No.
And start from 2. Your value is
So
0.135. So
but it's not.
it's not the CP. Reject it. Come on. Not CP, not accepted. Because domain start from 2. Yes or no? Come on.
So
Okay, now next condition. Now take the denominator equal 0. Okay. Means we have two conditions for CP. Number one, derivative 0 and derivative undefined. So please, what happened in the derivative become undefined? Which part becomes 0 and undefined?
denominator.
Denominator. Now equate this one equal to 0, please. So the down part is n square times ln n power 3, am I right? Is equal to 0. Okay. If two functions are multiplying and answer is 0, it means n square is equal to 0 or ln n power 3 is equal to. Okay. From here, and how much? Accept or reject?
Reject because it's
Because,
not from 2 to
No,
7.
no, don't say anything, but please. N is 0. My domain start from where? 2. Please, check the domain, please. Question, start from here. 2. And your answer of n is what?
0.
So please, it is not covered in the domain, please. 0 is out of, from 2 to 3 is out.
So no series.
So it's also rejected. Come here, last thing, please. From here, ln n is equal to 0. N is equal to e power.
0.
How much it is that?
1.
So accept or reject?
Reject.
So unfortunately, we could not find any CP. 2 to infinity, there is no CP, understand? What I need from here basically. No, what's our objective? What we are doing? Why are we doing this thing? Decreasing. We have to take what? Decreasing. Okay, good. Now, for decreasing purpose, anybody knows next step? I think we remember. Calculus 1. Good. For decreasing now, draw your domain line. Our domain is from where to where, please? 2 to positive. In look at the question, please. Look at the question, please. From 2 to infinity. Okay. How many CPs we get? 0?
We didn't have any.
No CP. Please don't say 0. There is no CP at all. Clear?
Yes.
Now tell me how to check decreasing. There is no point coming on the domain line because there is no CP.
It's increasing.
Take the points.
We have to take test point. 2 to infinity, any test point, please tell me.
4 and 3.
3, it's okay. Substitute where?
And the
Up where? In the question. Please substitute where?
derivative.
First derivative. Yes. The behavior of the function, increasing, decreasing, always check by first derivative. Substitute this 3, please, in your first derivative. Tell me the answer is positive or negative? Negative. Negative means function increasing or decreasing? First, we check. It's decreasing function.
So,
Yes.
can we cancel this one?
Minus Mr.
That's a خلاص all into bit in terms of.
Okay, so now, decreasing, oh yes. This tab has marks, okay? Now, we have to check about the question. The question is converges or diverges. Now calculate its integration.
What if it was increasing? What is the reason?
No, if it is not decreasing, means any property is not here, you cannot apply this method. Okay, but of course, in exam, we give you that question who has all three.
Can we just say it's decreasing because we know?
You have shown, it has marks. Don't show, okay, we don't have marks. Just like it decreasing, so we decrease the marks. Yes, please. No, we have to check now. We not check. The rule.
Yeah.
Okay, now we, which test we are using here? Integral test. We need integration. If integration answer is a number, a finite number, so it is converges. And if the answer of integration is infinity, this is a rule. This is a rule for integral test. Right now, we just check three conditions. Can we apply this test? Yes or no? We just confirm. Now start the integration. Integration is easy. It's not difficult, please. I can just wherever I can apply. Okay, start now, please. We have time. Okay. Now look at here. How to integrate? This sigma change what? Integral sign. Yes. When look at here. Integrate from where to where?
Two to positive.
2 to infinity positive. And because we are using n not x, so dn. dn divided by n times ln n and square. Now it's time to integrate.
And as you.
Yes, exactly. But before to integrate, this is which integral? Improper, 8.8. Now I'm just giving a review of 8.8. So I told you, there's no new technique for integration. The old technique, this is 8.8. Chapter, sorry, 9.3 is totally 8.8. Improper integral. Means you have upper limit or lower limit is infinity. And you know very good because you already have done improper integration. Still you are basically doing the practice. So I hope you have the idea how to, get this integration piece. So yes, so limit t approaches to cos infinity, integrate to t and dn divide by n times ln n and square. Okay. Now start substitution. What will you guys do? ln n is u, so dn over n is equal to
du.
Please, now no more any different thing, please. We have done already this stuff. So don't worry at all, okay? Oh yes, only this third part, this takes time because we need the differentiation, okay? Right. Now limit t approaches to infinity, please. So now dn by n is du. And n is u, it has square. Yes or no?
Yes.
Please integrate du by u square. How integrate?
Take
Take it out. It becomes negative to the right. And use a power of integration now. So n plus 1 over n plus 1. So if you don't mind, it is basically negative. Yes, I took outside of limit negative sign. 1 over u, right? U is what? U is ln n. Very nice. So use ln n, please. So put here ln n and tell me the limits from where to where?
From 2 to t.
2 to t. Very good. From 2 to t. Good. Okay. Let me make it separate. Okay. Now upper limit in the answer minus lower limit in the answer. So now negative sign limit t approaches to infinity. What is the upper limit, please?
T.
So 1 over ln t. Very good. Minus lower limit
And
ln 2. Very nice. Good. Now, this is you have negative sign. Come on. This t take what? So look at it. ln
One
ln infinity. 1 over infinity.
Zero.
How much? Very good. So this portion is 1 over infinity becomes 0. And this is minus 1 over ln 2. Okay. This minus and that must become what? 1 over ln 2. Is it infinity or finite answer? Finite. So the series
Conversion.
converges. This implies that the series converges, please. Because answer is a number, not infinity. Hope you understand. Clear? Good.
But the answer is not
The answer is
it's not 1 over 102.
the answer.
I mean the value of the series, the value of the series is not.
No, the series answer is 1 2 by.
So this is the answer.
Yes, it is that one.
It was just.
It is converges. Converge means the series going towards a point.
Yeah, the point.
And we have calculated the point is 1 over ln 2. I think 0 point something means if you look at here.
So it's not just.
If you expand open the series means put n2, 3 and add them. So the answer becomes 1 over ln 2. 0 point something.
No, it's 1.44.
Sorry, 1.4?
Yes.
1 point. It's converged to 1 point something like that. Okay? Yes, if answer is infinity, then series diverges. A positive infinity, the infinity diverges. Clear enough? So this is a story about integral test. Let's take one more last question, please. But the same pattern question. It means I just take question for your interest, please. Okay, let's see. Which question I can take? Okay. Take 37. 37. En divided by 1 plus e power 2n. 37, please. 37. En divided by 1 plus e power 2n, sigma is 1 to infinity. By using integral test, you have to check this series converges or diverges. 37, please. 37. En 1 plus e power 2n. 7, let me take a new page. So 37.
Equal
Sigma n is equal to
1.
1 infinity
Equal
e power n divided by 1 plus
equal
e power 2. Okay, good.
2 and
12. Now, check positive because from 1 infinity you can put any point positive. Okay, so P, yes, C,
Continue.
continuity,
Yes.
Yes.
of course, yes. And now D, you have to check now. Actually, of course, it is D, but it has marks. You have to show the steps. Not class. So your marks are class, okay? You don't write like that. Okay, it is D. Yes, done. So decreasing. You said decreasing. I decrease the marks. Okay, without that one, because it has some points. Not very high points, but because we give the advantage to students. Okay, means if at least they start some initial step correct, so we accept it. Anyway, please start. My function is e power n divided by 1 plus e power 2n. Okay, f prime. We need f prime, please. Quotient rule, yes, no other option. So e power n times 1 plus e power 2n minus e power n
E.
was that times e power 2n times 2, am I right?
Yes.
And divide by 1 plus e raised to power 2n. Okay.
It's supposed to be squared.
Squared plus b squared.
Oh, yes, yes. U prime v minus u v prime over v square, okay? Right, so now I think it's better. If I take the e power n as a common factor, so that to find the critical points becomes more easy for us, okay? So if you take e power as a common factor from the numerator, what we can get?
One.
1 plus e power 2n, because this en is here, okay?
And
And
minus two.
minus 2 times e power n, okay, good. And divide by 1 plus e power 2n, and it has square. Understand? Okay, you can combine. This is 1 e power, is negative 2 e power. So if you combine, how much? Negative 1. Yes, good. So this is 1. This is minus 2. So minus 2 plus 1. Negative 1. So please, you can delete from here and make it negative what? Negative 1. Understand? Yes, no. I just simplify, please. Now, that's it. It's enough, right? Enough. Now you can try for the CPs, critical points, please. Okay, start now. My first derivative has this shape. So, CP first condition, equal to 0. When 0? When numerator is 0. Substitute numerator equal to 0 and try to get the n value. Look at here, En times 1 minus e power 2n is equal to 0. So if the product of two factors 0,
So.
it means factor number 1, En is equal to,
0.
very good. Factor number 2, En is equal to 0. Now I need n. How I get n from this equation? Ln both sides. So look at here. N is equal to ln 0, which is basically undefined. This is negative, but you can, that does not exist, don't worry. The answer does not exist, please. Not defined, not defined. Understand why not defined? Ln 0 is undefined, negative infinity. Please, come here. On the side, so e power 2n is equal to 1. Okay. And then both sides, please. So 2 2n. So 2n is equal to 0 and n is equal to 0. Check domain.
That's not.
No?
That's like 1.
Just from the one.
It's.
Negative 1. Yes, you're right. Because it is negative sign. Oh, I'm sorry. So defined. Undefined, please. Because when you apply both sides ln, the negative argument. Oh, yes, please. When I move this one, positive. So I think I was correct, am I right?
Yes.
Just write it. And how much? 0. Okay, domain. Domain. From 1 or 2? 1. So 1. And of course, now ready. Now yes. Here you get the negative sign. Yes, from here, because when you take it equal to 0, so it becomes negative 1, and then on both sides. Again, because take the now denominator, make it equal to 0, please. 1 plus e power 2 and power 2 is equal to 0. From here, e power 2 is minus 1. Apply and both sides. So what happened? Does not exist. I mean, undefined. NCP what? NCP, the same situation like the last question. Draw the main line, please. Domain line, sorry. Domain line. From where to where?
From 1 to positive.
1 to positive infinity. Kindly select any test point, please. Okay, good. 2. Where substitute?
First one better.
Here, please. Here. Come on, check, please. See, down is positive because it has square. Don't waste time. Only check up. Please. Negative? Very good. So Negative means decreasing. Done. So our third condition, yes. Now it's okay. Yes.
You got CP and all with that.
You have to put now then CP on the domain line. Let's say your CP is for example 2, for example 2.
Then we take between the.
Yes, let's say your CP is 2, for example here 2. So 1 to 2 check behavior, 2 to 3 check behavior, yes. Of course,
And we just, if there was like positive and negative.
very good question. Let's say here positive. And here is,
Negative.
Okay. now check. The negative behavior is how long?
From
How long?
the positive or negative?
Think, the negative behavior. Decreasing is how long?
It's going.
Now look at here. The increasing behavior is limited from 1 to 2. The dominant behavior is what? So this is decreasing. Opposite, good question. Means
cases,
then, for example, if it is here, it let's say increasing. Now then, the test fails. The test fails because the function only decreasing from 1 to 2. Then actually, it is not it is meaningless. Doesn't make sense. But we can say that now you apply integer test only from where to where. Yes. But it doesn't make sense, please, because we are talking about the series, infinite series. Okay, so we cannot use a finite length. No, it is doesn't make sense at all. This condition does not make sense. It never happens, please. Okay, either becomes infinitely increasing. So please just stop. Please no more. Test fails. Condition not justify. Test fails. Anyway, question not finished. We have to integrate, please. Now come back. Integration of this function. How you integrate, please?
Limit tends to.
Okay. Good means it's okay. Limit. I understand. Limit. T approaches to infinity.
From 1
Integrate 1 to t. Tn divide by 1 plus e power 2 and dn. Yes. How to integrate? Yes. En is u. Okay. Good. So e power n is equal to u. Then e and dn is equal to du. Correct? Go next, please. Limit. T approaches to infinity. 1 to t. Dn is du over 1 plus u square. Agreed? Understand? I can write e power plus u square. Yes or no? Yes. Okay, look at it. Because why? Look at it. This e power 2n, you can write e n square. Can you write 2n like that? Power and power, they become multiply. Yes or no? N power 2 to n. That's why. What is en equal? U. That's why I change this to u and just square becomes u square. This is u square. How to integrate du by u square? 10. It's never, leave you behind you. 10 inverse. Till the end of this chapter, please. So don't forget this 10 inverse, please. That's why I'm telling you 3 rules of integration: secant inverse, sine inverse, tan inverse. Please, you will use frequently, please. So now, finally, this is limit t approaches to infinity. Now you have, okay, a, how much a? 1. Basically, the rule is that 1 over a. So 1 by 1, 1 over a, right? Tan inverse x over a means u over a. Okay, so tan inverse, if you don't mind, what is u is?
A power n.
A power n. Okay, over a is 1 normally. It has limit from where to where?
From 1 to 3.
1 to 3. I'm sorry, actually, when I substitute, not put limit, please, okay? Because it is u now. Okay, now please, upper limit in the answer and lower limit in the answer. So limit t approaches to infinity. How much upper limit? E. So tangent inverse e power t and minus tangent inverse
E to the power.
e power 1. E power 1 is e, okay? E power 1 means e, okay? Now, this t will become what?
Infinity.
So it become infinity. What is e power infinity? So tan inverse what?
Infinity.
Very good. And minus. By the way, tan inverse e, you can check, is a finite number, yes or no? Yes or no? Don't write the answer if decimal. Keep as it is. Tan.
That's it. Tan inverse infinity pi over.
Oh. Yes. So pi over 2 minus tan inverse e. This is our answer. The answer is finite number or infinity. Check.
Finite number.
Pi by 2 minus tan inverse e.
Tan
Right.
inverse E is a number.
Is a finite number. So your question converge or diverge?
Convert.
Converge. Very good. This implies that your series, the series, question number what? 37. This series converges, please, because its integration answer is a finite number. Series converges, please. Series converges. So again, please, there is no new thing you have learned now. It's 8.8, improper integral. Okay? And the decreasing you have done, calculus 1, how is the decreasing? First derivative. Get the idea? That's it. This is all about 9.3. Okay? Right. So, inshallah, we'll upload the announcement in Teams that